Hello, everybody, and thank you, Stéphane, for the kind introduction. So I will present an example of adoption of ARCADIA and Capella to develop a specific elimination process of radioactive waste by melting. The subtitle of my presentation is important. It's a beginner's experience that I will share with you, as I had not used Capella or followed the ARCADIA method before. The outline of my presentation is the following. I will start by introducing CERN, the research organization where I work, the context, some facts and figures, and what it means to manage radioactive waste at CERN. I will then pass to the process specification. Just to be clear, I will not go into the details, the technical details of melting radioactive waste. I will present you just some pictures like the one that you see here on this slide, where you see actually our metallic waste that is cast in ingots. I will rather focus on the way the process was developed, was specified, with the limitations of the current practices that we have at CERN, the causes and the approach that I followed to, let's say, overcome these limitations. I will then present the proposed solution by the ARCADIA method, the Capella tool, and some of the examples of the diagrams in use, operational architecture, capability diagrams, and scenarios. And I will end with some words on the add-on M2Doc that was instrumental in my work. I will then wrap up with some conclusions. If we then start with CERN, here you have an aerial picture of our installations. Our installations are circular colliders that are represented here by the blue circles. The red line in the picture is the Swiss-French border. And as you can see, our installations are located on both sides in the two host countries. To have an idea of the size of our installations, you can compare our facilities with the landing strips of the Geneva airport that are at the bottom left. CERN was founded in 1954. This year we celebrate our 70th anniversary. It was founded to foster peaceful collaboration between the nations that were enemies during World War II. Today, it has grown in a quite large international organization with 24 member states, and the challenges are different. You have to imagine that we have now Israel as a member state and Pakistan that is in the process of becoming a member state. We are about 10,000 workers every day on our sites, 2,600 staff, and so on. As an international and intergovernmental organization, we are not subject to French or Swiss laws, which might let you think that we have quite some freedom in managing our activities, radioactive waste in particular. But actually, though we have the right to establish our own rules, in the end, with the agreements that we have with the host states, it ends up that we use the most restrictive rules, in particular in our field, in France and Switzerland. The situation is even complex if you think that we are installed in a almost rural area where we have to transport our components, radioactive components on public roads, collect them, and manage and process them for final disposal. Every year, we produce about 500 cubic meters of radioactive waste. This is nothing to be compared with the kind of radioactive waste that you have coming from a nuclear power plant, yet it is a challenge. And we have a waste processing facility capable of 1,000 cubic meters per year and 10,000 cubic meters of interim storage. It comes from various experiments, radiation areas, from our accelerators. If you line up all of them, we have 50 kilometers of accelerators and so on, with some specific facilities. The challenge is how to manage this activity in compliance with the rules. I will not talk about the radiation protection, let's say, challenges, but specifically the elimination of radioactive waste. What it means, essentially, you can think of an accelerator as a vacuum tube in a very, very simplified way, where you have the particles that are flying around. We have pumps, vacuum pumps, to make to empty the tube of air, to make a very good vacuum, then magnets to electromagnets to oblige the particles to stay within the tubes, accelerating cavities to increase their speed, and then, as you can imagine, it's an electrical machine. We have thousands of kilometers of cables that have to be periodically exchanged because their electrical insulation becomes fragile. Again, I will not go into the technical details. We have very limited contamination, is low activity, but yet it needs to be managed. How it is done, and also to understand the reason for the process that I will discuss. We pay by the volume. So our waste is classified according to its radioactive radiological content, and then it's eliminated either in France or in Switzerland. We have, first of all, 30% of our waste that is only on paper radioactive. Actually, we can prove by measurement that this is not the case. And then we can recycle it in Switzerland. And the cost in this case for the final disposal is 0 Swiss francs, 0 euros per cubic meter. And we can even recuperate some resources from the valuable materials such as copper. Then 64% about of our waste is slightly radioactive. It is eliminated in France, where it is stored in a surface facility, where it is monitored, and after 300 years, it has become conventional material. Radioactivity has the nice, let's say, feature that it fades away with time, and this kind of waste after 300 years is just conventional material. The price for the storage in surface storage and monitoring is 900 Swiss francs, slightly less than 900 euros per cubic meter. The situation is more challenging if we go to higher level of waste. About 5.5% of our waste, again, you can see in the top left picture, is metallic. It's intermediate and low level, so the radiological content is higher, and it goes to reinforced concrete structures in France. It is again a repository where our waste is kept, monitored 300 years. Again, after 300 years is conventional, but still the managing of the facility requires financial resources, and in the end, per cubic meter, we pay 26,000 Swiss francs. It is even worse if we go to the 0.2% of our waste. It is the last class. It goes to its long-lived intermediate and low-level waste. It goes to Switzerland, where it is kept temporarily, waiting for a geological repository. Its cost is 242,000 Swiss francs. As you can see, we pay by the volume, and we have all the interest in reducing this volume, which means compacting it, and theoretically, the best we can do is to melt this waste, because in this case, we achieve the highest possible density, the density of the metallic ore. For this reason, we have launched, it was 2017, a program to process our waste by melting. Here at the left, you can see a picture of the induction oven that we identified as suitable for our to process our waste. You can see also that the operator is close to the oven as a proof that our waste is not as radioactive as the one that you have in nuclear power plants. What you get at the end is that the molten metal can be recycled within the nuclear industry. You can make tubes, or it can be cast in ingots, cylindrical ingots, that you see at the bottom right picture. The program included a setup phase when we did a technical market survey. We defined the strategy. We set up also ancillary activities to melt our waste. And then in 2020, we were ready to launch the project, the pilot project to melt a batch of metallic components coming from our accelerators. And then the project went quite fast. It was May 2020, we launched the pilot project. May 2021, we had the first container filled and available for measurements. Then 1 year later, June, we had all the first batch finalized. We had the audit by the French authorities. And then it went so fast that a few months later, we could melt all our waste and then eliminate it. And Capella and ARCADIA were quite instrumental in this fast pace of our project. And I will come on the reason and why it was so possible. But first of all, how can we set up such a process? Well, let's say that's me with all the specifications and requirements coming from the French authorities. In the end, as I said in my introduction, we have to comply with the most restrictive set of requirements, which in our case meant 49 specifications, and then we can extract from these specifications 241 high-level requirements. And high-level requirements means that you can ask for a derogation, but then you open a Pandora box with many new requirements popping up to prove that your activities are still safe and compliant with the rules and regulations. Within CERN, this kind of problems is traditionally managed by text documents alone. It is possible, but then you need quite a good team of engineers and resources and time. We also developed a specific graphical notation to convey the technical information with actual drawing packages that are used to create these diagrams and so on. The point is that we approach, for instance, with our process, a painful limit of 1,000 requirements that I found in some pictures, in some references like the one by Pascal Roque and Hetherington, that becomes quite painful to manage the traditional way with Excel lists and text documents. So I asked myself, well, let's try let's see if there is a different way of doing things. And I studied more or less the kind of possibilities. In MBSE, there is a maturity model that was published by Holt and Perry in 2020, where you can classify an organization into 5 classes, 5 stages, going from a purely text-based document organization, stage 1, to a model-based organization, stage 5. And CERN presently is stage 2, document-centric. And if you look at the icon, is even worse than stage 1, because to the text documents, you add all the diagrams that you use. As I said, since 2015, CERN uses a specific business process modeling notation that resembles, for those who know it, BPMN 2.0. You have a small example, a typical small example here at the left bottom of my slide. Again, these are just, however, drawings. There is a syntax, there is no semantics in it, and it deserves quite some attention when you draw such diagrams. The text documents that are the main vector today to gather the technical documentation, the technical information, to specify the processes have limitations. And personally, I experienced these limitations. You have complex consistency checks across the documents, loss of consistency as the specification evolves, and especially the statement of the problem is mixed up with the technical solution that you propose, which means that you have time-consuming validation, difficulty to assess and control the change requests, poor control of versioning, and something that I experienced again is the definition of supplier's delivery, for instance, the foundry for our to melt our waste, is sometimes weak, not sufficient, and this leads to addendum to contracts to rework. I tried to address these problems, and actually the first limitation is human mind. As I said, with the number of specifications of requirements for processing by melting radioactive waste, we go to a limit where a human mind alone is unable to master this complex information. So we need to break down the specification, this is an approach, the text documents into elementary sentences, and thoroughly manage each sentence one by one, which is the requirements engineering approach. In this sense, you are helped by software tools like IBM Rational Doors ProR, and personally, I tried InnoSlate. Unfortunately, this is just one of the limitations, and you have to face the other one, that is limitation two. In any case, you use the natural language, so text, that sometimes is not the best to convey the technical information. And then you need ad hoc specific artificial notations like the universal modeling language, system modeling language, and similar. But there is a third limitation, is that a method is needed. That is a path to follow, going from the statement of the problem till the solution. And it is there that I crossed ARCADIA, and I found some good textbooks, theory, software textbooks. I give you here the references, and you know it. You have quite a wealth of information available on the net. Coaching is available also. So my learning experience, the perspective was positive, and I decided to give it a try. Then I went to my colleagues, and I have to face the situation that is presented in the cartoon here on the left. They were too busy with the traditional way of doing things. And of course, they were busy because it is really heavy. On top of these, there are some barriers, like financial barriers, software cost. For instance, this was one of the reasons that prevented me from using some software tools. But Capella, and this was one of the reasons, at least for my problem, for my simple problem, it is open source. And as I said, self-learning and training coaching was available. So it looked promising, but there was a problem. That is, I manage waste, and waste is not a product. We do not work to produce waste, of course. It is just the end of life stage of any equipment. On top of this, waste management is not a system. It is a complex operational process, but it is an operational process. So in principle, ARCADIA and Capella seemed unsuitable to develop the melting process, as they seemed to support only the stepwise development of equipment and systems. On top of this, you set up a project in Capella. The first step, the operational analysis, is even optional. However, I told myself the operational analysis has similarities with our modeling notation, with the advantage that it is more rich, and in addition to a syntax, it has a semantics. So the elements in the drawings have a meaning, and you cannot manipulate them as you wish. And although it was just a tiny bit from the operational analysis level, it seemed still interesting, and I made the attempt to use Capella and ARCADIA. The model that I built was developed by the book, defining by a capability diagram, first of all, the goal, then subdivided into objectives for my process. I developed it in Capella 5.1, then I upgraded 6.1. Now you have even version 7. As I said, it's just the operational analysis where I defined one main process, two sub-processes for a total of 69 activities. In the end, the model is accessed by 11 diagrams. 1 plus 2, I say 1 plus 2 because I have the top process and the two sub-processes. So 1 plus 2 simplified architecture diagrams, 1 plus 2 capabilities diagrams, 4 entity scenarios, and 1 state machine diagram. There are additional diagrams that are used, such as an activity interaction diagram, detailed operational architectures, but just for model construction. I made also an attempt to use system analysis and logical architecture to model the CERN quality management system that seemed to me the only thing that could go through system analysis and logical architecture. However, these steps ultimately proved unnecessary for demonstrating compliance with the authorities' requirements. So in the end, the operational level alone was enough. The result is that I gained 6 months of work, 6 months of my professional life. Capella provided a comprehensive set of diagrams that addressed all design needs. Here on the left, you have a simplified example of the operational architecture of the top process with the actors, the, let's say, yellow-orange boxes for their activities. And I noted also on the diagrams the, let's say, low-level operational documentation for the technicians, like quick reference cards, templates, layouts of the work site. Beyond the model and the low-level operational documents therein referenced, no additional documentation was needed for designing, auditing, and implementing the process. The diagrams served as a clear basis for discussion, and what was interesting to me was the differences in the educational backgrounds of the actors played little or no role at all. In principle, the process has to be analyzed and presented to engineers, to physicists, to technicians. And when I use, for instance, our CERN notation that we have developed in-house, I found that it was indeed clear to engineers, understandable by physicists, but for technicians was not the best. With Capella, I had really no problem. The discussions went through smoothly. And also, communicating with the auditors was effective. So effective that the process was approved the very same day of the audit. And in this sense, we really gained a lot. I reused the model to develop an elimination process for the waste that cannot be melted. The development took 12 months instead of the 18 months that are normally required. And in this case, I was more attentive to the time spent. And again, it is a gain of 6 months. Why? I asked myself the question, why did I gain 6 months? I was asked the same question. And a first, let's say, answer is, of course, as the saying goes, that a picture is worth 1,000 words. So diagrams are extremely effective in conveying the information. However, I do not think that this is all the story. In my opinion, there is also a second point. There is, in a sense, a second development axis that exists. Let me explain. When I say that ARCADIA guides you from the statement of the problem to the solution, going from what I call here on the left of my slide, first development axis. So you go from operational analysis, system analysis, and so on, until the end product breakdown structure. That's only part of the work. There is actually at the first level at least, a second development axis when you go through the actors. So you have to present and translate and develop let's say, tackle the problem first with the engineers, then you retake it and you rephrase it with the physicists, then you go with the same set of information, you retranslate it to the technicians, and then you iterate to be clear and be sure that all the process, all the information is consistent. So this axis is there, and the traditional text-based approach progresses along this line with documents that are addressed to these different stakeholders. And the model's information is therefore repeated and adapted to the reader. Capella and ARCADIA led me, in a sense, to develop the process in one go, which streamlined the information sharing and avoided repetition. On top of this, the semantics facilitated the impact analysis and the changes requested by the stakeholders. I noticed also, and this was quite interesting, that the stakeholders' attention shifted from the text to the process itself. That is, in the standard traditional approach, they were asking for changes in the sentences, in the sections of the text document, but then when it is reflected in a diagram and Capella modifies the diagram, but also all the other diagrams, then you understand that you are not asking for a change of a sentence, you're asking for a change of something more. And their attention again was shifted. And here I come to M2Doc, because my colleagues, the stakeholders, are not familiar with MBSE, cannot access the model. So having a text document is mandatory, especially at the very first stage. But the document itself, and this is a quotation from a book by Holt and Wilkins, text documents do not own any of the knowledge specific to the model. And in fact, they should be perceived as just another set of views that make up the model, albeit it is a text-based view. And this was the case. It was clear to the actors that the text documents were just views. They were not the subject that we were discussing. Indeed, in the end, in the text document, they were based on a template. The template had only a set of contextual information common to all elimination pathways, and then it was all that was in the document was diagrams and tables. In the end, only 10 pages, where you can also add as an annex the operational documentation, the quick reference cards that I mentioned before as annexes. As a, let's say, comment, this operational documentation can be added as an annex without version number. What it means, once you have a process approved by the authorities, then it is frozen, which means that you cannot change a comma unless you go through a sometimes heavy reviewing process. But ARCADIA and Capella guided to me to structure the documentation in several levels. And again, only the top document, 10 pages, was frozen. The operational documentation was mentioned, annexed, but without version number, which means that we have still the flexibility to integrate the lessons learned during operation. Some final remarks. I use the model extending it to all other elimination processes, really all other elimination processes of radioactive waste. We have some tens of them at CERN, for instance, for the other classes of waste that I mentioned at the very beginning. And I discovered that actually we are doing always the same thing. So these are not different processes, but it is one and the same process. So I could unify and consolidate the roles and operational activities. And this extended model is now adopted. Its views are now the standard process reference. Still, Capella is not yet adopted. This, despite it is a user-friendly, personally I find it a user-friendly software, and despite the objective results that you save time, it is not straightforward, even from I went to my young colleagues, young physicists, young engineers, but it is not easy for them to go from start to the finish line. That is from the statement of the problem to the solution. Probably something more than youth is needed to, let's say, to gain the MBSE mindset. Other remark, the French auditing authority was surprised, and I was surprised that they were surprised, because as I understand, Capella and ARCADIA have been developed by Thales in France, so I did think that it was, let's say, known. And what I see is probably that there is a misconception between MBSE and what it is called a digital twin. That is a 3D CAD model of your system. Then somebody thinks of my, let's say, partners thought that an engineering model is a digital twin, so this 3D CAD model, but in the end, at least in my opinion, these are two different things, and it is not. Another final remark is that life cycle analysis could benefit. So let's say this approach could be beneficial in other domains. We have been recently asked, as many industries nowadays, to assess the environmental impact of our activities. And there, the suitable implementation of the so-called second axis of development that I mentioned before could be interesting. The situation is the following. The information to assess the environmental impact of a component or of a system, it is usually not known, it's not owned by only one actor. So for instance, we know we have all the information to assess the environmental impact of waste, but we know very little about the components that we receive in our waste processing facility. We know very little of those components while they are used or while they are built. So this information is spread along that second axis. To assess the environmental impact, what is done today is that you hire a contractor, and then the poor guy goes all through your organization trying to collect all the information and to perform the analysis. Now, if there would be a tool that allows everybody to input in a model, the part of the information that for the environmental impact that he knows, let's say taking care from the gate of his facility, from the entrance gate to the exit, as we do, for instance, with our processing facility, then that could gain in efficiency, integrating information that otherwise is dispersed across an organization. Well, that's it. Let me conclude then with a short summary. So I made this experience, this beginning experience, to use the ARCADIA method to conceive and specify efficiently a process for the elimination of, by melting of our ferrous, low-level and intermediate-level metallic waste. And Capella was instrumental in doing otherwise. So in this transition from the traditional approach in use at CERN to the new MBSE mindset, M2Doc was indispensable to interact with the stakeholders that are not familiar with this approach or the Capella tool, and it produced a very concise text documentation, again, 10 pages, and that's it. The method and the tool ensure the quality requested by the French auditing authority to meet the acceptance criteria set by the foundry and the final radioactive waste repository. The model gave also insight on all other elimination processes, unifying and consolidating roles and operational activities. And as I said, my last remark, the approach could have potential benefits in other domains. So streamlining environmental life cycle assessment. And thank you for your attention.
An excellent presentation. We now have time for a few questions. So did you use Capella to manage your requirements and also to trace them from high level to lower levels of requirements?
So I did try, there is an add-on for managing requirements, but in the end, I refrained from it also because we do not have at CERN a specific software to manage requirements. In the end, they were embedded into the model and in the text document. That was enough, but otherwise I did not use Capella otherwise, let's say. That's my experience.
Okay, can you elaborate on the prospects you have in mind for Capella at CERN? Do the benefits you have proven trigger some interest for additional use?
Okay, within the team, yes. As I said, I had to face this difficulty of change of mindset. Uh, At CERN, we have internally a forum to discuss project management issues and tools or new ways of doing, and I'm active there. I will present it. At the moment, I cannot say more, so hopefully, because I believe in it, but at the moment, it stays limited to my section. I also exchanged with my colleagues that are involved with the life cycle assessment, so the environmental assessment, and they were interested. But again, they are physicists, so they do not have the MBSE mindset yet, but they do see the interest. So there could be an opportunity there as well.
Yeah, and maybe as a comment on that, you may be aware that at Obeo we have an eco design for Capella add-on,
Yes.
which enables the synchronization and exchange of information between architecture and lifecycle analysis assessment tools. But yeah, maybe a follow-up question where you said at the beginning of the presentation that your colleagues were a little bit skeptical at the beginning, and they were basically too busy to look
Yeah.
at this new type of ways of doing things. And then that you tried to push that again, I guess, after a while, and that it was not straightforward to newcomers. So you know, how would you explain that? I mean, in the sense that you were able to try Capella, learn ARCADIA on your own. Why do you think is it so difficult maybe to extend that to your colleagues?
Uh, Honestly, it is not yet clear to me. There are some difficulties that are inherent in changing the mindset once you studied and you are brought up at university with text-based, the traditional approach, let's say. I understand that can be difficult. I must say also that, for instance, setting up a template for the text document by M2Doc can be difficult. It's not straightforward at the very beginning. So uh, if that part would be easier, then I guess it also my colleagues would have been more, let's say, uh, would have bought the new way of doing. It is true that in the end, once you set up the template, then you don't touch it anymore and you reuse it one and the other time. So I cannot, apart these inherent difficulties, I cannot, let's say, mm, add something more. Also, I do not know, I understood that there is no, let's say, open source free version of Team for teams for Capella, that could have helped, as for instance, the open source free version of Capella was instrumental to this first trial. But if you have not a way to interact uh, with the same model, somebody who's knowledgeable and you that are starting can pose some problems. These I can understand.
Are there regulatory requirements to validate machines, processes that are used for the higher level operational processes you modeled? And if so, could system, logical, and/or physical architecture have been helpful to support that validation work?
Oh, yes, definitely. They were not applicable in my case because actually we selected an external foundry that met our needs. So we did not build that facility. But in a sense, if you have to build to define a tool, a system to process radioactive waste, yes, of course, when you need such an approach, and the Capella, ARCADIA, in this case, would be helpful to support this activity. So again, my example was simple and limited just to the operational level, but one can think of other cases, yes.
Thank you, Luca. I'm gonna bring in the next question. Was your first step in Capella copying the 49 specifications one by one into your Capella model?
That's not straightforward. No, no. The approach is different. Is going really from you have to change the perspective. Instead, starting from the text documents, even the specifications, the requirements, when I started from the problem. So the goal of the process, then the objectives, and in defining the objectives and the actions, then I integrated step by step their requirements. And at the end, I cross-checked that all the requirements were indeed taken care of by an element of the model, depending at which level, either by an activity or by the layout of the working area or by a quick reference card, but everything should be there. So it's really reversing um, uh, the setting up of the problem.
Right, thank you. How and when do you determine the amount of detail to be defined in the model?
That's a very good point because, and I experienced it also, uh, over specifying and building too complex a model is one of the, by experience now, I know, is one of the mistakes that you can make. And it is mentioned as a mistake in the textbooks that I referenced in my presentation. I said that I tried to go, for instance, to the system analysis, logical analysis, but in the end was not needed. What is the exact amount of detail is set by the stakeholders, and in this sense, the authorities. So in the end, the approach that I followed is I did the very minimum, and then by an interaction, a frequent interaction and the unofficial exchanging with the exchanges with the authorities, I understood where they needed more information, where they did not, and that's it. So one has to start from the need rather than what you think of the stakeholders, then from what you think is the need that they might have. You have to question the stakeholders.
Thank you. The ARCADIA method is from the top down. Have you ever tried reverse engineering?
Well, no, I have not. We have some software tools that we use. I did try, honestly, to um, let's say use one of them, to model one of them, but I cannot conclude on it. So it's not concluding my experience in this sense of reverse engineering. No.
So I may add a comment here to say that, in my opinion, the ARCADIA method is not top-down. It's usually presented in a top-down manner because it's kind of easier to understand that way at the beginning. But it's kind of what we are seeing is that in more than 50% of the cases, ARCADIA and Capella are used with an existing system, and that is being evolved or modernized, and in a lot of cases, it's actually used in a bottom-up or in a mixed approach, and the method and the tools are actually supporting this type of usages as well. Did you also model operational scenarios to address any alternative scenario, for example, when something goes wrong?
This is a very good question. It goes to safety management and quality management. Yes and no, in the sense that the approach that we followed is to things can go wrong, of course, whenever you do something, which means in our case that the packages that we produce for melting, they do not conform with the requirements. But instead of setting it as a, let's say, as a problem, as an incident, is for us introduced in the different activities. We have a specific step of quality control, and we intercept these things that are wrong, and we treat them. So in this sense, they are built in the process. We do not have a specific scenario just for, let's say, unexpected events. All that can happen is managed by the process, eventually by going back with loops that take you back to the previous step or some steps before, and you redo the process.